Okay, so now we're starting section 2.2, which deals with linear equations. All right, so let's talk a little bit about the term linear. Okay, what does that mean, linear? Yeah, so exactly. So linear, right? If you break down this word, it has the word line in it, correct? So basically it's dealing with lines. Okay. All right, particularly straight lines. Okay. So lines that correspond to slopes, right? So you can have four types of slopes, right? You can have this kind of slope or this kind of line. Okay, so let me just do this, right? So this one, you can have this kind of slope or this kind of line, this kind or this kind. So in this case here, if we have this kind of slope or line, what kind of slope is this one? The first one. Exactly. It's going to be positive, right? This first one is going to be positive, right? It's an incline. It's going up, increasing. Okay. What about this next one here? What's this going to be? If this is positive, this has to be what? Negative. Good, right? So this is negative. It's a decline, right? It's decreasing. It's a decreasing. What about the third one here? What's that going to be? What's this one here? Mm, it's a good word, but it's just going to be, if you think about somebody flatlining, right? If somebody's flatlining and say that their heartbeat, they have flatline, that means what's their heartbeat? Zero, right? If they have flatline, that means their heartbeat is zero. So this means the slope here will be zero, okay? Because they have flatline. There's no more beat. Okay, what about this next one here? What's that going to be? The one's vertical. This one's going to be undefined. Okay, that's undefined. That's normally represented by this, like a zero with a slash. Okay, so that's going to be undefined. All right, and I'll talk about more later why it's undefined. Okay, so now when we look at these different equations, all right, and this is the part that I want to emphasize that in order to do well in math, you have to understand the graph behind the math. Okay. So as I mentioned, I alluded to the slopes, but they're being derived from what? Y is equal to mx plus b, correct? All right. So this is the slope intercept form. Okay. This is the slope intercept form. You've probably been introduced to this since you were in elementary school, correct? So m right here, right? That's our slope. B, okay, this is the B right there. B, that's our y-intercept. Intercept, okay? So we just talked about the slope. The y-intercept is if you have use a different color here. You have an x and y axis, right? You have an x and y axis where it crosses. Here's our y axis, here's our x axis. So where it crosses the x-axis, that's going to be your y-intercept. So in this case, if I have a line right there, where it crosses it, that's my y-intercept, right? It's where it's intersecting the y-axis. That's what that literally means, okay? So if we analyze the y equals mx plus b, rewrite that here again, What do you notice about the x? What's the power of on the x there? What's the power on the x? So I'm looking at this right here. What's the power there? 1. Okay? The power is 1. All right? So in order for it to be a line, the power here has to be an integer of 1. Can't be a fraction, can't be a square root, a decimal, or anything like that. It has to be an integer. Okay? All right? And it mm, has to be 1 or bigger, right? In order for it to work. Right? But again, it has to be an integer. Cannot be a decimal or fraction or anything like that. Okay? Unless it's 1 over 1 or 2 over 2, it produces 1. All right? As long as it produces an integer. Okay? 1 or bigger. All right. So let's look at this then. Let's analyze this first. We need to figure out whether this is linear, right? Is the equation linear? If it is linear, then we need to put it in this form. That's what it's saying. Okay? But first, let's figure this out. Is this linear? Okay, that's our question. Is this linear? All right, so let's look at the first one. Is that one going to be linear? 2x plus 1 is equal to 0. Yes or no? It is, right? Number 1 is going to be linear because the power there is 1. So yes, I'm going to put a check mark. That's linear. What about the second one there? Is that one linear? I got a fraction in the front. Is this linear? Ah, you fell in the trap. This is linear. The only part and the only time it's not, it wouldn't be linear if the fraction was as a power. So if it was x to the 3/4, then it wouldn't be linear, right? So this is still linear because the power of this one is still 1. Okay? So even though we got a negative 3/4, that doesn't matter. We're talking about the power on the x. So this is linear. Okay, what about this one? Is this one linear, yes or no? Yeah, so number 3, this one is not going to be x, right? This one is x to the 1, but again, now we got multiple x's. Okay? So that's multiple x. So that's going to change. It's going to change how the graph looks. So in this case, since 2, we have a power of 2 here, okay? This is not linear. Okay? Yes, so is one only one is linear. Yes. Yep. Okay, what about the next one here? Is this going to be linear? Yes or no? Right. This one's not going to be linear, right? Because square root of x, does anybody remember what's another way to rewrite square root of x? Well, another way to rewrite square root of x, it's not 0. Okay, it's nope, not 1. Yeah, it's going to be x to the 1/2 power. Okay, square root of x, right? Because this is a square root. You can have a cubic root, right? A cubic root is going to be what? If square root of x is x to the 1/2, what's going to be um, cubic root of x? What would that be? X to the what? 1/3, right? If I have the fourth root of x, what would that be? x to the what? 1/4. Okay, you guys got it? Makes sense? Right? So whatever number is out here, I just write it as a fraction form. Okay? So this is dealing with square roots or some kind of root. Okay? And root. So in this case, Dan, would this be a linear? Right? It won't be. Right? Because again, we have square root of x, which is x to the 1/2. Remember, the exponent has to be what? An integer. Cannot be a fraction, a decimal, anything like that. So this is not linear. What about this one? It has a decimal in it. Is this going to be a linear? Fell into the trap again. Remember, we're looking at the power of x. I don't care about this. These don't matter to me. Okay? We're looking at the power of x. Okay? So the power of x here is 1, so that's going to be linear. Okay? What about this one? Is this one linear? Yes, good, right? This is linear. If I multiply this, it'll be what? 1/2 x plus 4/2. Okay, it doesn't matter. The power there's still 1, right? Even if I distribute this 1/2, the power is still 1. So it doesn't change anything. So this one's linear. How about this last one? Yes or no? Okay, this one's going to be no, right? Why? Because we have a power of 3, right? So we can't have anything bigger than 1. So that one's not linear. Okay, so now we've understood. Okay, questions on. So we saw part 1, now we're doing part 2. It says after you determine whether it's linear or not. Uh, if it's linear, give values for A and B that result in this. So basically we have to uh, write it in this form, and then if it is in this form, we need to determine the A and B. Okay. Okay. So I just have to put everything to the left, right? Because the right side has to be 0. So I'm going to subtract. So for the first one there, use a different color here, right? We have negative 2x plus 1 equals 4, right? So that's linear. Subtract 1 on both sides. Negative 2x equals 3. Oh, no, sorry. Try to solve for x. I don't want to solve for x. I want to move everything to the left. So subtract 4 on both sides. We get negative 2x minus 3 equals 0. So now I have it in this form. Okay? And that's what they want. And then that's my answer there. Okay? So in this case, then A is going to be negative 2 and B is equal to negative 3. Okay? All right. Excuse me. So that we have that first one. The second one, we don't have to do anything because it's already in this form, right? It's already in where the right side is 0. So you got negative 3/4 x equals 0. All right. So in this case, our A is going to be negative 3/4, and then B is going to be 0 because there's nothing there. All right. So again, we don't have to do anything extra for that one. Okay, what about the third one there? Again, this is not linear, so we don't have to worry about it. This one's not linear, so we don't have to worry about it. But we do need to worry about these next two. Okay. So we have negative 5.7x minus 3.4 equals negative 6.8. Okay. So again, we just need to move that right side to the left. So we're going to add 6.8 on both sides. Okay. So we get negative 5.7x, okay, plus 3.4 equals 0. Okay. So in this case, A is negative 5.7 and B is 3.4. Okay. All right, and then for our last one there, right, we have 1/2 x plus 4, right? So we just need to distribute that. Okay. So when we distribute the 1/2 x plus 4, that's going to give us 1/2 x plus 4 over 2, which is equal to 0. So we have 1/2 x plus 2 equals 0. So A is 1/2 and B is 2. All right, so for this next problem, all they want us to do is complete the table. So they give us the equation we're working with, and they tell us the values for x. So for the first one, x is equal to negative 2, right? So we plug that in here. So we have 9 minus negative 2 plus 3 equals 4. Okay. Okay, so what do we get here? Okay, I kind of jumped the gun on this problem. So there's two parts to this problem. First, it wants to complete the table, and then we want to solve the equation numerically. So the first step is we need to plug it in, which I did originally. Okay. So when we plug it in, we get 9 minus um sorry, 9 minus 8. Sorry. I'm doing negative 2 plus 3. There we go. Okay. So negative 2 plus 3, well, that's going to give us 1, right? So 9 minus 1 is 8. Okay. So that's why they got 8 here. Okay. Then we do it again. So x is equal to negative 1. So we have 9 minus negative 1 plus 3. So that's going to be negative 1 plus 3 is going to give us 2. So 9 minus 2 is going to give us 7. Right? So we put 7 here. All right, so that's what they want us to do. Anyway, to save us on time here, we continue this path, right? So this pattern here. So x now equals 0. So 9 minus 0 plus 3. 0 plus 3. Again, when we're trying to simplify or solve, we need to, well, when we're trying to simplify, we need to do order operations, right? So we do inside the parentheses first. That's why I'm focusing on that first. So 0 plus 3 is 3. 9 minus 3 is going to give us 6. And then x equals 1. So 9 minus 1 plus 3. So that's going to give us 9 minus 4, right? Which is 5. Okay, and then we have x is equal to 2. Right? So that's going to be 9 minus 2 plus 3. Okay, so that will give us 9 minus 5, which gives us 4. Okay, so we have 8, 7, 6, 5, 4. Okay, so we completed the table by doing it this way. All right, and then the next part is then solve the equation numerically. Well, we find out, right, because it tells us they want the output to be 4. So in order for the output to be 4, x has to equal 2. Okay. So again, in order for the output to be 4, x has to equal 2. So the solution, okay, to 9 minus x plus 3 equals 4 is when x is equal to 2. So that will be the answer there, right? So this is based off of just plugging the values in, right? This is what they mean by solve the equation numerically, just plugging it in. All right, so here we want to solve this, right? Well, they want us to solve and check. Okay. All right, so we want to get x by itself, so we do the opposite operation. So we have plus 3 here, so we're going to subtract 3 on both sides, right? So we get 1/4 x. This is going to give us 0, right? And then 9 minus 3 will give us 6. Okay. Now I can do two ways here. I can either divide both sides by 1/4, all right? Or I can just multiply by the reciprocal, okay? So I'm going to do on the reciprocal, 4/1, right? So then the 4's here will cancel. 1/1 is 1, so that gives me x. And then 6 times 4/1 is 24/1, which is just 24, okay? So that's our answer there. All right, so the second part is they want us to check, so we already solved it, right? X equals 24. So to check it, we just plug in our value for x. So 1/4 times 24 plus 3. So 1/4 times 24 is the same thing as writing as 24/4 plus 3. 24 divided by 4 is 6. So 6 plus 3 will give us 9. So that's the solution we have, and that's what the solution that they gave us originally. Okay, so this is the checking part. Okay, so the next question is going to be really vital to understanding about this whole topic. Okay, so I'm going to use this next question to expand, hopefully, your knowledge of this. Okay, so again, same thing, we want to solve and check. So let's look at this problem. We have 12y minus 6. I'm going to put x there. It doesn't matter what variable you use. You can use any letter you want, but let's just put 12x minus 6 equals 33 minus x. Okay, so 12x minus 6 equals 33 minus x. Go ahead and see if you can solve that. And once you have your answer, go ahead and post that. Okay, so walk me through this, right? So what's our first step here? How do I solve this? Okay, so we're going to add x, all right? There's a lot of ways to solve this, right? So this is one way. Okay, so add x, so we get 12x plus 1x is 13x minus 6 equals 33. All right, what's the next step? Okay, add 6. So add 6 to both sides. So that cancels. We have 13x equals 39. All right, what's the next step? Okay, divide by 13. Good. Perfect. Okay. So x gives us what? 39 divided by 13 is 3. Good. Right? Here's my question. What does this mean? Okay. You've been probably doing this since you were in middle school, elementary school. We have an answer. What does this mean? Okay. We solved it. Great. But what does it mean? I'm going to pause it here. We have this. Okay. So my main question was we go through solving this equation. We found out x equals 3. And my question was, what does this mean? Okay. So, and I'm going to answer that in as I talk about and elaborate on this. My follow-up question is, how many equations do we see? So remember we talked about we are dealing with um, y equals mx plus b, right? We're dealing with linear equations, y equals mx plus b. So in this case, we have two equations, all right? One equation is y is equal to 12x minus 6, okay? So y1. Y2 is going to be 33 minus x, okay? So those are our two equations. They're two separate equations. But what do they represent? What kind of equations are this? What kind of graph do we have here? What are they? What did we say this was? We're talking about what? What kind of graph? Lines, right? These are lines, okay? So this one will have a positive, right? Because this is a positive slope. So we know that this is going to look something like this, right? This has a negative slope, so it's going to look something like this. So if we were to graph this, okay, if we were to graph this, let me pause here for a second. Okay, so if we were to graph this, the 12x minus 6 will look like this, right? Like I said, it was a positive slope. The 33 minus x, okay, will look like this because I said it will be a negative slope, all right? And what was our solution? What was x equal to? 3, right? X is equal to 3. So if I click on this point here, what's going to be this point? 330. Okay? The x coordinate is 3, right? So what we're trying to solve is, or we're trying to do is, we're trying to figure out where do they cross, okay? Or if they cross at all. So in this case, we got x equals 3. So it's telling us at x equals 3, this is where these two equations cross. That's the bottom line, okay? All right. If we plugged in 3 in for x, then our y value would be 30 for both of them. But anyway, we're trying to figure out when we have an answer, a solution, what does that mean? That means at x equals 3, that is where they cross. In fact, I propose to you that there are going to be three possibilities, right? So we just talked about the first one. Okay, so we're going to have solutions. Okay. So we have this kind of graph, which I just showed you. Another graph we'll get is this kind. Another graph we'll get is this kind. So this one, right, we said there is one solution here. What about the second graph? What about here? How many solutions will we get for this one? Second one. How many solutions will I get for this second one here? None, right? Why is it none? Why is it 0? Yeah, they're parallel. They'll never cross. Okay? They'll never cross. That's why, here we had this solution, right? X equals 3. This one we might have like say 5 is equal to 4. That doesn't make any sense. So when we solve this, we get this as an output, right? Like that doesn't make any sense because it's telling us these two will never cross, right? There's never a point in the coordinate plane where they'll ever cross. That's why you get zero solutions. What about the last one here? Infinite, exactly. This will be infinite, infinitely many solutions, right? Because they're basically the same equation right on top of each other. Okay? So any point you pick on that, it's going to be a solution to this equation because they're the exact same thing. Okay? That is the reasoning behind math. If we understand the graph, that's what I tell my students. If you understand the graph and how the graph works, then this stuff here makes more sense. But if you have them separately, independently, then it's not going to make any sense at all. But I encourage you to understand the graph. If you understand the graph, how it behaves, then we understand how the equation is related to the graph. This is why students have a hard time relating to math because they do these two things independently. If we understand the graph again, then we understand how the equation, okay, how it works with the graph. Okay, this is the meat of it. Okay, we have to put these two together in order to understand mathematics. Okay, so for example, and again, this is just if you give me x squared, right, automatically I can tell you it's a parabola. Okay, we're dealing with parabolas. If you give me x to the third, we're talking about this types of graph. Okay, all right. So if you give me square root of x, I know it's going to look something like this. All right. All right. So because I understand what the graph or the equation and how the equation is related to the graph. And now I have a better way of saying, okay, how is this equation, or how can I use this equation to understand what the graph is doing in this case? So, but again, I just don't look at these, I just don't look at this independently. I don't look like what is x squared? It doesn't make any sense. However, if I, again, correlate it with the graph, then it makes a lot more sense. X squared and this parabola, yes, I know that. X cubed and this graph here looks like a little s. Yes, I know that. Right? Square root of x, right? I know that. Okay? When you get into trig, right? So y is equal to sine of x, right? That means I start at 0 and I go up and then down, right? That's a sine function, right? So anyway, that is the beauty of math, understanding how the two relate to each other, the equation and the graph. When you start learning it that way, it makes a lot more sense. Okay, so let's look at the first one. We got 1 minus 3x plus 1 equals 5 minus x. What's our first step here? What do we do? Distribute. Good. Okay, we're going to distribute. Okay, so we have a negative 1, right? We have a negative 1, so we're going to distribute the negative 1 to each term. So we got 1 minus 3x minus 1 equals 5 minus x. Perfect. Okay, now we combine like terms on the left side and on the right. So we got 1 minus 1 here, so that's going to cancel. So we got negative 3x equals 5 minus x. Okay, now what? Let me pause this. All right, so we have 1 minus 1 here. That's going to give you 0. Negative 3x, 5 minus x. Okay, now what's our next step? What do we do next? Add x. Good. Want to add x to both sides. I can also add 3x to both sides. Doesn't matter. In the end, we'll get the same answer. All right, so let's add x to both sides. That's fine. Okay, so that cancels. So I got minus 3x plus 1x. That gives me negative 2x equals 5. Okay, and then our last step here is just to divide everything by negative 2. So x gives us negative 5 over 2. Okay, all right. So it wants us to check it. So let's check it real quick. Okay, so if I plug in negative 5 over 2 here, for x, we'll get, let me use a different color. We get 1 minus negative 5 over 2. Sorry, I meant 3 times negative 5 over 2 plus 1 equals 5 minus negative 5 over 2. Okay, so we have 1 minus, well, we have to have a negative there, so to distribute each one in each term. But before we do that, let's go ahead and simplify the inside here. So we have, so let me backtrack. Okay, so 1 minus, we have negative 15 over 2 plus 1. Okay, so we have 1 minus, I'm going to distribute the negative 1 in each one. That's going to give me a plus 15 over 2 minus 1. Okay, on this side. So again, I have a negative 1 times a negative 15 over 2. That's a positive 15 over 2. And then minus 1 times 1 is negative 1. And then these ones will cancel, leaving me with 15 over 2. Okay? All right, so this side I should get the same. So we get 5 and then plus 5 over 2 because negative is a positive. I need to multiply this by 2 over 2. So that gives me 10 over 2 plus 5 over 2. 10 plus 5 divided by 2 will give us 15 over 2. So we get the same on each side. So that is correct. So this is the checking part. Okay, let's look at the next one. We have the 6 plus 2 times x minus 7 equals 10 minus 3 times x minus 3. All right, what's our first step here? What's our first step? Distribute, good. So we're going to take the 2, we're going to multiply to each term, take the negative 3, multiply to each term. So that gives me 6 plus 2x minus 14, and I have 10 minus 3x plus 9. Okay, then I combine the left side and combine stuff on the right side. So we got 6 minus 14, that's going to give us negative 8. So that's 2x minus 8. Then we got 10 plus 9 is 19, so that's negative 3x plus 19. Okay. All right. Then what do I do next? What's our next step? Good. We're gonna add, well, because I have a positive 2x. Okay. If I want to do 2x, and because I need to get rid of it, then I want to subtract 2x. Okay. So this is already a positive. So I don't want to do another positive because I'm just making my problem more complicated. I'm trying to get rid of some terms. Okay. So instead of positive, we want to subtract 2x. Okay. Now, I can also do that, but I have another negative here, so which is fine. But I recommend I would subtract the ones that's a lower. Okay. So in this case, negative 3x is lower than 2x, so I'm actually going to do the opposite of this. So I'm going to add the 3x, add the 3x. Okay. So that cancels. And now I have 5x on the left side, and I don't have to worry about the negatives anymore. Okay. And then we add 8 to both sides. All right, so that gives us 27, and then divide both sides by 5. So x is 27 over 5. Okay, so now we need to check it. So we solve for x, so now we need to check it to see if our solution is correct. Okay, so, all right, so we're going to have 6 plus, let's try to use a different color here. So we have 6, again, we're checking. We got 6 plus 2 times 27 over 5 minus 7 equals 10 minus 3 times that by 27 over 5 minus 3. Okay. So this left side, we're going to have 6 plus, and I distribute the 2 in each side. So, where do we get that? 54. Okay, so that's going to give me 54 over 5, and then minus 14. This side we have 10 minus, okay, 27 times 3 is 81, so that'll be 81 over 5 plus 9, because again, I'm doing it for every single term. Okay, 6 minus 14 is going to give us negative 8, so 54 over 5 minus 8. All right, so I want to combine my like terms here, or I need to subtract this. I need to have like terms, so I'm going to, or have the same denominator, so I'm going to multiply this by 5 over 5. So that gives us 50 over 5 minus 40 over 5. Okay, so that gives us 14 over 5. 54 minus 40 is 14 over 5. All right, so this side we do the same thing. 10 plus 9 is going to give us 19 minus 81 over 5. So I multiply top and bottom by 5. So 19 times 5 gives me 95. So 95 over 5. Okay. Minus 81 over 5. That gives me 14 over 5. So they are equal. So check.